Welcome to the 14 July 2020 episode of IBM Developer Puget Sound. Topic: Git Survival on the Command Line. Software configuration management is for distributed, collaborative coders who need to keep track of code changes that will be merged with other contributions, view differences, and possibly revert to a particular commit state. The following examples will be tested with Fedora 31 Linux on an x86 64-bit architecture with Git version 2.24.1 and Python version 3.7.4. We'll start by initializing a project from an existing repository. First, I'll clear the screen and we'll make a workspace for ourselves. Once the workspace is created, we'll change into it. And we'll clone a repository from GitHub. Now that the project is cloned, we'll notice that it created a directory for us that has the same name as the repository name. And if we change into that directory, we can see the projects or the files in that. We now have a clone of the files, and we can take a look at them if we want, or edit them. So this would be what you see on GitHub when you go to this repository. Well, it's rendered rather than, this is the raw format. So this is editable. But we're here to look at Git, so you can do things like check the status, and you'll note that it tells you what branch you're on and how it compares to origin, which is the default name, the default name of the remote repository, and it says there's nothing to commit, working tree clean. So that's the first thing you want to do when you pull it down, or any time to tell what's going on, is git status. We can do git branch, and we see that it has only downloaded the master branch. If you need a different branch, you have to specify that branch directly. And we can look at the history of commits. So here you can see first 7, numbers of this commit relate to the insights network and if you can see it, it's hard to see, but if I click on it, it'll go to, so this is the latest commit, and that number, there's 7 digits there, and those should match the 7 digits that are in this commit message right here. And you can see that the messages are the same, the author, date, and so on. So we have copied, cloned, literally cloned, the project that was on GitHub into our temporary directory here. That concludes our introduction to initializing a project from an existing repository. So now we will remove our temporary working directory and prepare for the next section. Another way to begin working is with a fresh idea. No code exists yet, or the code exists, but it's not yet managed. So we will make workspace, no, we will make project directory, and we'll call it this project. Then we'll change into that directory, and we'll initialize the project simply with git init. And it gives us a little hint. It says initialized an empty Git repository and tells us where. It's in this project, and it's in a directory labeled .git. So we should be able to check the status of our project, and it says we're on branch master, no commits, and we haven't made any changes, so there's nothing to commit. And if we just take a look at everything in this project, we'll see there's also nothing in that in the directory except the new Git directory. In order to commit to the project, Git expects some authentication. So we'll work on how to do that. First we need to change into workspace this project, and you can see that we're already there, and we'll configure a username, and we'll configure a user email. And now we can see the change that has been made. you can see there's a user with a name equal to your name and the user's email equal to your email at yourdomain.com. Notice that this sets the Git username and email address just for this project, as in it's not global. So alternatively, we could set a global Git username and email address that would be valid across multiple projects. We'll take a look at that in a minute. Setting a global Git username looks a lot like the local except that we've added the dash dash global. And now we'll add the global email. And we'll see the changes that have been made. Well, this certainly raises an interesting question, and we'll get to that later in this tutorial. But right here you can see that the changes have been made according to our configuration command, and you can see that they were done at a top level in a directory called git config. Actually, that would be a file called git config. And then down here, these lines are commented out, and we'll, as I said a minute ago, we'll take a look at what those lines mean. Apparently, they were there, and Git commented those out and added this line. Finally, we can issue the command git config and after issuing git config list, we can see there's a global name and a global email, and a little bit farther down that there's a local name and a local email. Whether that's a good idea or not, having different names and different email addresses is up for experimentation. Let's assume that we made some configurations to the username or email that were incorrect, and we want to remove a config parameter. So the way to do that You can see that we've unset both the local username and user email, and we've unset the global user email and the global username. We can now list with Git the changes are confirmed. Both the local and global usernames have been removed from the configuration file. There are some caveats. You need to know in advance what your upstream repository will be expecting in terms of a username and email. And whatever user email you do choose for the configuration file will be attached to the commits and made a permanent part of that record. And if you want to hide your email address on GitHub, you need to see the about commit addresses. It just so happens that I've pulled that up so that we can take a look at it, and you can see on the bottom of the screen the link to this page. And if we scroll down, there's a section that specifically talks about hiding a personal email address. Lower in the page, we find that if you'd like to keep your personal email address private, you can use a GitHub provided no reply email address as your commit email address. And then here there's some description about the syntax of that email address, and there's two different syntaxes depending on the date, one before the date and one after. Furthermore, let's make some code changes to our project. These will be our initial changes. So notice that we're in our workspace and this project directory. And we'll test our code to make sure that it works. And indeed, the code is functioning. And let's check our Git status. And it gives us some new information. It tells us what branch we're on, that we haven't made any commits, and that we've edited some files that are not being tracked yet. So there's a new file. We know that. We just created this file right here with that command. And it gives us a little hint. It says nothing added to commit, but untracked files present. Use git add to track. So that's the next thing we need to do, is git add. And that's what we will do. Now we'll check the status again. Note, there's a change in the messaging. Up here it had a list of untracked files. Now there are no more untracked files, but there is a new file called Hello World that's staged, and ready to be committed. Henceforth, we'll take a look at commits. Uh, and before we talk about the all-in-one commit, I'd like to take a look at the conventional commits message guidelines. So the guidelines are a specification for adding human and machine readable meaning to commit messages. And if we scroll down to the summary, we can see there's an option scope and a description. And the option scope includes something like fix or feature, or maybe some alternate types: build, chore, continuous integration, and so on. Scrolling down a little farther, we can see there's some examples, and we can see that it starts, the message description starts with a verb, and it's lowercase, and the description is fairly short, in some cases very short. So we're going to try to copy that in our commit messages as well. First, we'll try an all-in-one commit message or commit command. So we're expecting this. We deleted this couple of sections above. We deleted the username, and now Git is telling us, please tell us who you are, run this command, run these two commands, and that'll set up an identity. Whilst paused, I added my username and email address, so these commits should work properly. So notice I'm using the all-in-one git commit message. The -m means message, and here the first message, and then another -m and a second message. We can check the commit by running git log one line, and we can see that the commit has been made, and the head is now pointing here. There's our commit message. Now if we want to change our commit message, we can do it with the amend command. Let's say we made a mistake in the message, spelling error, or we just totally got it wrong. Maybe we forgot to put, forgot the wrong syntax, or, who knows, something. can see that the commit message has been replaced. The next thing we want to do is push. So let's take a look at that. Git push refers to a remote repository, and we'll talk about that in a while. But in some cases, you may want to push after every commit if you want to keep your project backed up. That way the local files are always copied to somewhere remote. So what this is saying is git push to an origin is a kind of a default name for the remote repository, but when you're setting up that remote, you could name it anything. So let's give this a try and see if it works. So you can see that I'm I have a repository on the IBM Cloud, and it's asking me if we like this, accept this machine. We're going to say yes, and it's permanently added. Depending on your project strategy, pushing after every commit is one option to keep your project backed up. And so we'll just give that a try here and see if we can push to the origin. Origin is a default name given to the remote repository, and I've already set that up, and we'll take a look at that later on, but for right now we'll just give this a try and see what happens. And it's going to ask for a password. You can see from the messages that it's gone through and it's pushed to our project out on the IBM Cloud, and it on the IBM Cloud or in the remote repository, it created a new branch and it matched the local branch to the master branch, and it's set up to track the remote master from origin. The result of our push can be seen in the remote repository by switching over to that. And here you can see we're in the IBM Cloud, and it's showing this is GitLab in the IBM Cloud, and this is probably going to be a separate tutorial looking at that. But you can see here that it's the push has been done and recorded.